In this video, I'll be going over the Chapter 7, Day 4 notes, which is over a new concept called logarithms. And a logarithmic function, or logarithm, is the inverse of an exponential function. And so the biggest thing to learn today is how to convert from a logarithm to an exponential expression or equation. So log stands for log. It's an operator. And every log is going to have a base. We'll call it b. And whatever the log is operating on, it is always equal to an exponent. So I'm using x as an exponent here. And the conversion is the fact that the base on the log is the same base with that same exponent of x. So make sure to write down this statement and all of it at the very top here. But you can, for problems 1 through 6, just practice expressing or converting expressions in exponential and logarithmic form. So if I want to express the following in exponential form, I will take the base of the log. Whatever the log is equal to, that is the power. And then I'm going to set that equal to the term in the middle. And this should be a true statement. 3 to the 4th is indeed 81. For number 2, it just says log of 1,000. It doesn't list a base number. So very, very important here. This is called the common logarithm. And the common logarithm always has a base of 10. Base 10 is the number system that we use on a daily basis in real life. So this is called the common logarithm because base 10 is the common base. The power would be 3. 10 to the third is equal to 1,000. So once again, you take the base, you take what the logarithm is equal to as the power, and then set that equal to the term in the middle. 2 to the negative first is equal to half, and those are all true. For number 4, to express it in logarithmic form, you're going to write log first. The base is the term with the power, and then the 729, and the exponent is always what the logarithm is equal to. So these are a little bit harder to check just because you're going in the reverse direction. So for number 5, it would be log base. The base here is a half, and then of 1/8, and that's equal to the power. So logarithm always gives you back, a logarithm always gives you back an exponent. So this number right here is always the exponent. So for number 6, I have a base of 10. You don't have to write base 10. So log of 1 is equal to 0. And this brings up a really important point. Your calculator can do log base 10. So you'll notice that I have the log button right here at the top, log. So for example, if I take log of 1, let's see if it gives me back 0. And there it is. I can't really check the rest of those. My calculator can only do base 10. So the question is, if I want to figure out what is log base 2 of 16, like what is that equal to? How do I solve that logarithm without using a calculator? Well, to solve this, you are going to convert it using the information at the very top. So I always set it equal to x, take the base, take the power, set it equal to 16. Now that I've converted it, you might have a better idea on how to solve it. So we know that we want to get bases to be the same. 16 is 2 to the 4th, and so we have x is equal to 4. So that logarithm would be equal to 4. And problem number 8, I want to know what the log of 100 is. So the base is 10. What power on 10 gives you back 100? And so your calculator could actually do this one for you, but if I work it out by hand, I do get an answer of 2. And I can verify that real fast. The log of 100 is indeed 2. For problem number 9, I want to know what is log base 7 of 7. So here the the base is 7. I want to know what power on 7 changes it to 7. Well, it doesn't change, so that means that x is just 1. For problem number 10, I want to know what power on 4 gives me back negative 16. And if you recall from the day 2 notes, there is no number or exponent that will change 4 to a negative number because of asymptotes. For problem number 11, I want to know what power on 2 gives me back 1. And so we talked about this as a special case. What power on any number changes it back to 1, and that's 0. So in essence, what you're doing is converting it to a problem from a couple days ago, and then you just follow what we learned in day 2. So the last one here, number 12, I want to know what power on 49 changes it to 7. And so the answer here is not 2, right? 49 squared is definitely not 7. So then I'm going to get bases to be the same. So I'm going to change 49 to 7 squared. I'll also put a power of 1 on that 7 because now that bases are the same, I can say 2x is equal to 1. So then your answer is going to be actually 1/2. And so we're going to talk a little bit more about logarithms, but if you can understand what we did, especially here with number 12, you're in really good shape. But more to come later.